Hello friends, my name is Anurag Jain. I am developer advocate with Thales. In this multi-part series, we are going to see how we can add compliances like PCI DSS or other compliances to web applications that are dealing with secure or sensitive information like users' credit card information or personal information. So we will in this particular series, I'm going to start with creating a three-tier app, a web application from scratch. And we are then going to see how we can add, encryption or data security transparently without us requiring to change this app itself. The focus of this application will be for storing sensitive information like credit card data, those kind of information that come under compliance lens, and they need to be stored in a way that it is secure and cannot be retrieved without proper controls. We will be using Thales CipherTrust data protection gateway and the community edition of Thales CipherTrust manager for this transparent encryption. This is a free tool, and we will look into the other parts of the series on how we can configure the same to work with our environment. To give a high level overview, I will be working, to start with, I will be working with a non compliant app, a multi tier application with UI, backend, and database that can be deployed in Docker. And the way this application is going to work is that the user can go to the UI. He can add sensitive information, and some of the use cases can be e-commerce where user provides sensitive information, or banking apps. So those are the kind of areas where such information is exchanged. So user goes to that front end layer and provides that information, which then goes to the backend. I'm using Spring Boot, but it goes to a backend API kind of layer, which then finally persists that information in a database. I'm going to use Mongo DB for that, but yeah, it can be any database. As you can see, this all this information, it's being stored in as this form, which is plain text, and it's not secure. If someone hacks the database, if he gets the access to the data itself, then he can easily get information which is really sensitive and critical. So we can solve this particular problem in different ways, and definitely tokenization and encryption is one of the standard ways of doing it. But that's not something which is easy to implement, and it does require a lot of management things in terms of keys management and key rotation and those kind of things. So here comes Thales CipherTrust Data Protection Gateway, which basically it's a transparent agent which sits in the same Docker environment. And what it does is it intercept that request, that REST request between the front end and API. And instead of passing that information as is, it can tokenize or encrypt information using policies defined on CipherTrust Manager. So we will talk about these configurations and policies in later parts, and how a data protection gateway can be deployed. But yeah, we are going to start with a non-compliant app first. So since I will be working on this three-tier application, the front end being in React and Express, backend APIs being in Spring Boot, and then MongoDB and Dockerization. So having a familiarity with these technologies is definitely good, but it's not mandatory. I'm using STS for Spring Boot, Visual Studio Code for React, and Docker for desktop. But you can definitely choose, the IDEs and tools as per your own liking. And in this video, we are going to develop the API layer first, and then in the next part onward, we will look into the other components. To build that, I'm using Chat GPT to generate the boilerplate code, just to reduce the scope of this demo. So I will be running this query on ChatGPT to get the boilerplate code, and if required, we will make any customizations to that. I have also put an expanded version of this example on GitHub, which you can also follow. So we can now move on to the development environment, and I'm using STS. So let me create a Spring project using Maven. I have just named it as sample API, PCI. I'm using Maven as the build tool and Java 17 as the Java version. I'm adding two dependencies. One is Spring Data MongoDB to interact with the MongoDB itself, and Spring Web because we will be exposing certain API endpoints to store the sensitive information as well as retrieve it. So while STS is generating the code, this is the Chat GPT command which I ran. So Spring Boot REST API to store the information. This is sensitive information, so definitely all the considerations should be there, but we will worry about them in later parts. Today I'm just going to add this code to make an API backend layer which can store the sensitive information and retrieve it as well. So I'm going to start with configuring MongoDB, and I will go to, this is my application in STS. So I'm going to add these configurations here. A couple of more things I would need to add is data.mongodb.username as root, and this is for my environment. It can be different for yours, and password is again root, and my database is dpg. Okay, uh, that should be enough from the property file perspective. Now let's go back and add the model class. So model class is our DB class, how the DB will be created. Or the collection in case of MongoDB. So we are going to create the collection credit cards, and these fields will be available in that. So let me create this class in our project. Up and finish, and I'm going to import the code as is, and I'm going to add the constructors and getters and setters. Okay, so model class is ready. uh, let's move on to creating the repository. So this contains all the required methods to interact with the data stored in MongoDB. So I'm going to create an interface with the same name, and I would extend this interface with Mongo repository. So I'm just going to extend Mongo repository with the model class that we just created, and finally our controller class. So that's where all the REST endpoints will be residing. In our case, there will be two. One is to save the information, and the other one is to retrieve. So this is the endpoint that we will be generating, and these are the two mappings that we are adding: the get mapping, which will return all the credit cards, and the post mapping, which will save that credit card. Okay, this should be it. Okay, let's run this application as Spring Boot app, and if everything goes well, we should be able to hit this URL with empty data. Okay, let's go and hit this. Yeah, so we have a working API. It's returning empty data because there's no data present yet. I can populate, data unit right now. So I'm sending the request on post to the same endpoint. And if we go back to our browser, we can now see the data. And as you can see, all the fields, let me just retrieve it. So as you can see in the backend, all the fields, they are stored as plain text, and that is the problem that we are trying to solve here. So by adding a dpg, we aim to protect this or tokenize this information in a way that even if someone gets a hold of it, it still remains useless to that particular person, right? So that's it for this particular video. I'm going to add more and more videos around the other layers, the UI layer, Dockerizing of this application, as well as the DPG piece. And I will add all the relevant links and everything as part of the video description. So if you have any query, please feel free to connect us on our YouTube channel. And if you like this video, please like and subscribe to the channel. Thank you.